In this video, we're going to find the domain of some functions. So for the first one, we have f of x equal x to the third plus 6x squared minus 8x plus 2. This is a polynomial. And when we talk about domain, we're talking about real numbers. So the domain basically is the permissible values that you could use, plug into this expression, function, and still get a real number. For polynomials, there is no restriction. As long as you recognize it as a polynomial, the domain is going to be all real numbers. So we can write it in interval notation, negative infinity to infinity, or in set builder notation, set of all x, such that x is real. So we can write it as negative infinity to infinity, which means it represents all real numbers. Or in set builder notation, the set of all x, such that x is a real number. Now for the next one, if you have a rational expression, in this case we have x minus 6 over x squared minus 25, make sure it's reduced, and then all you have to do is basically look at the denominator. You cannot divide by 0. So for a rational function, in this case, we're looking at all real numbers that don't make the denominator 0. We can factor the x squared minus 25 into x minus 5 and x plus 5. You can see here that if x is 5, you get 0 here. 0 times anything is 0. Or if x is negative 5 plus 5 is 0. And then 0 times the other factor is 0. So those produce a 0 in the denominator. So for this one, set builder notation would be the set of all x, such that x does not equal to plus or minus 5. Now in set builder notation, you can look at it this way. Got minus 5 here, plus 5 over here. You have infinity on this side, minus infinity on this side. So we're allowed to plug in any number except negative 5 or 5. 5 is not allowed, so there's be an open circle there. Negative 5 is not allowed, open circle here. So it's everything this way, everything included in between negative 5 and 5, everything to the left here. So in interval notation, this would run from negative infinity to negative 5, and then it's union negative 5 to 5. Parentheses here means the negative 5 and the 5 are not included. Same thing over here. Parentheses, negative infinity always has parentheses, never a bracket. If the negative 5 and the 5 are included, you put brackets on them. So you have this, and then it's union. Anything larger than 5, any number larger than 5. So 5 to infinity. So that's the way you handle then polynomial functions and rational functions. Again, for polynomials, domain is always all real numbers. For rational functions, you have to restrict the numbers and make the denominator 0. So just set the denominator, if it's reduced, start with this. If not, reduce it first and then set the denominator equal to 0 and find out what the restrictions are. In this case, it's negative 5 and 5. Everything except negative 5 and 5. For a function involving a square root, the square root of a negative is not a real number. So we're only looking at real numbers. So all you have to do is take the radicand. 5x minus 8 has to be greater than or equal to 0. We just solve this inequality. Adding 8 to both sides doesn't change the inequality. Dividing by 5, positive number, doesn't change the sign of the inequality. So we get domain then would include all values that are greater than or equal to 8/5. And I would write that in set builder notation. Or I could write it this way. Brackets, because the 8 over 5 is included. You can take the square root of 0, that's going to be real. But if 8/5 there, I get 8 minus 8, 0. So this one can be written in interval notation. Brackets, 8/5, comma, infinity. Now for the next one, we have a function has a radical in the numerator, a radical in the denominator. So first of all, we know then that this 14, because it's under a square root, this radicand has to be greater than or equal to 0. Solve this, add x to both sides, we get this. So 14 is greater than or equal to x, or you can say x is less than or equal to 14. So that's one restriction. Now the denominator, we have another radical, so we know that 5 plus x has to be greater than or equal to 0. Let's isolate the x. Let's add negative 5 to both sides here, and we get x is greater than or equal to negative 5. So we know then x has to be less than or equal to 14 to satisfy these conditions, and x has to be greater than or equal to negative 5. Also, since this radical is in the denominator, remember, you can't divide by 0. So 2 minus the square root of 5 plus x. This cannot be 0. So we have to restrict that number. So we can go ahead and treat it as a regular equation, so we can find what number we restrict. So let's add a radical 5 plus x to both sides here. This will give me 2 on this side, and that brings this over. So what would make this equal here? We square both sides. 2 squared is 4, and then you square the radical, you get 5 plus x. And you add negative 5 to both sides, and you get x equal to negative 1. So we have to restrict this, okay? Because that's going to make the denominator 0. Put a negative 1 here where the x is. 5 plus negative 1 is 4. The square root of 4 is 2. 2 minus 2 is 0. So this one has to be restricted. So if you look at this then, in a number line, we want x to be less than or equal to 14. So let's put 14 over here somewhere. That's one condition. And notice it has equals here, so this is a closed circle here. 14 is included as part of the domain. And then what else do we have? This condition has to be satisfied. X has to be greater than or equal to negative 5. So let's put negative 5 over here somewhere. And that can be included. So I'll put a closed circle here. And then what else is restricted? X cannot be negative 1. So let me just put negative 1 over here somewhere. Cannot be negative 1, so this is open. For that, it's everything except negative 1. So this goes this way, this goes this way. So you can see the intersection of all these regions, and it's going to be in here and in here. So the domain is going to be contained between negative 1, or negative 5 and negative 1. Everything in there, the negative 5 included, the negative 1 is not. And then to the right of negative 1, everything, the negative 1 not included, everything to the right, up to 14. So for the domain, for this one then, I'll write it in interval notation. So brackets here, because the negative 5 is included, comma, to negative 1. That negative 1 is not included, so that's parentheses here. And that's union or together with everything to the right of negative 1. So this will be parentheses again. Negative 1 is not included. All the way up to 14. 14 is included. Brackets here. So this is your domain for this function. Everything between negative 5 and negative 1. Negative 5 included, the negative 1 is not. And then together with everything to the right of negative 1, all the way to 14. The 14 is included, the negative 1 is not. Thanks for watching. We'll see you next time.